All right, hello. Today we're going to, for this lecture, this is Multiplying Polynomials, Chapter 6, Section 2. Our goal is that we want to multiply polynomials and we want to use binomial expansion to expand binomial expressions. So you'll see how that works. It takes a little bit of you getting used to, but with practice it's pretty easy. So let's look at actually the first thing, the multiplying polynomials. We're going to start off with multiplying a monomial to any type of polynomial. So here we are going with that. The main idea here is that we want to use distributive property. So keep that in mind. You want to use distributive property for this. So every term, that means like whatever's on the outside has to multiply everything on the inside. Keep in mind that as you do this, you've got, say, when you're doing, like, say, an x squared times another x, make sure you're adding the exponents, but the coefficients you're multiplying. So I'm going to show you how I would write this out in step. So to show that I'm doing this as distributive property, I'm going to say it's 3x squared times the x cubed plus 3x squared times the 4. Okay. Now, since I'm saying 3x squared times the x cubed, that would mean I would add the exponents, and that would give me x to the 5th. So I'd have 3x to the 5th for the first part. Then I would say 4 times 3, multiplying those coefficients. 4 times 3 is 12. That would give me 12x squared. Very simple, not hard to do at all. That's all you got to do. Now, what about if I have just variables? Something like this, where I have AB times A cubed plus 3AB squared minus B cubed. Again, I'm going to show you distributive property, so I'm going to write this out where I'm multiplying the AB to every single thing, and I'm showing that I'm multiplying them all. Now you can draw arrows or whatever to get that, but that's, what I would recommend to at least, get you started. Make sure you don't miss anything. Now the first one, A times A cubed, that's a to the first times a cubed, which would be a to the 4th. And then put in the b. Then I can add in the ab times 3. So ab, 1, think there's a 1 right here. 1 times 3 is 3. A times a would be a squared. And then b times b squared, b to the first, b squared, 1 plus 2 is 3, b cubed. Okay, that takes care of that one. And then I would go to the next one, the negative times the positive. Negative times the positive would give me a minus. A multiplies by itself, so a. B to the first times b cubed would give me b to the 4th. That's one of the more complicated examples for that, but that's all you got to do. So now let's look at multiplying polynomials. And you've probably done this before in Algebra 1 with using FOIL method. Really, FOIL method is just distributive property. Now I'm going to show you two methods, and actually the book even introduces a third method, but I'm going to show you how to do this horizontally and how to do this vertically. I prefer vertically, but let's show you this one also. So here's my example for horizontal. X minus 2 times x squared plus 3x minus 1. Now the key point here is this. You've got to remember, again, we're doing distributive property. So every term in the first one has to multiply every term in the second one. So that means the x has to multiply the x squared. The x has to multiply the 3x. And then the x has to multiply the negative 1, or the minus 1. Then you also need to have the minus 2 multiply the x squared. The minus 2 multiply the 3x. And the minus 2 times the negative 1. When you multiply all of those, you will end up with x cubed plus 3x squared minus 1x minus 2x squared minus 6x plus 2. Combine your like terms. So combine your x squareds and your x's, and you finally end up with x cubed plus 1x squared minus 7x plus 2. Okay, so that's horizontally. vertically is like two-digit multiplication. Think of what you did back when you were in elementary school, where you did, like, say, a little number like 12 times 13. Okay, so let me, actually the thing started going faster than I wanted it to. Okay, so we're going to say now the negative 2 times the negative 1. Negative 2 times negative 1 is positive 2. Then I'm going to take the negative 2 times the 3x. This whole first row, top row, is going to be the negative 2 times that polynomial. So negative 2 times 3x is negative 6x. Then I'm going to say negative 2 times x squared, which is negative 2x squared. Then I'm going to now take the x times that top polynomial. I will start on the next row, and I will start under the x, because we're starting under the one that's multiplying. So x times negative 1 is negative 1x. X times 3x would be 3x squared. Positive. Notice I'm also writing the plus and positives when I have those. X times x squared is x cubed. And everything lines up here, so all I got to do is add or combine my like terms. They're right there in front of me. I can see them fairly easily. And just combine them. Negative 2 plus 3 is 1. Negative 1 minus 1, or negative 6 minus 1 is negative 7. And then bring down to 2. Okay. And that would be vertical. You may have also seen box method. If you have any questions about the box method, you're more than welcome to ask me, but I'm showing you these methods. I prefer the vertical method, but I do see times when the horizontal method has its advantages. So whichever one you feel comfortable with, you can do. This is not one where you have to do any method. Okay, so keep in mind that the main thing you have to remember here is that you're always making sure that every term in the first polynomial multiplies every term in the second polynomial. That's the key. As long as you do that and then combine your like terms, you should be fine with this. Okay, so now we get to expanding a binomial, like raising something to a power, basically. Like, so I'm going to have here, like, just trying to raise it to the power. And I'm going to show you how you could do this the long way. And then show you how you can simplify this. So we're going to do x plus 3, or x plus y to the third power. That means x plus y times x plus y times x plus y. It's the same thing as, like, 7 to the third power means 7 times 7 times 7. When I multiply x plus y times x plus y, the first time, I get x squared plus 2xy plus y squared, multiplying those two. Y'all should know how to multiply those. You could do it by hand, or you can do it with a vertical, whatever method. Now that one also that answer needs to multiply a third x plus y. So when I do that, I end up with, now I'll do this vertically. I've got the y cubed plus the 2xy squared plus the x squared y. Then I'm going to do the x times the y squared. That's a 1xy squared, 2x squared y, and then x cubed. Combine my like terms, and I end up with x cubed plus 3x squared y plus 3xy squared plus y cubed. Okay. That could get harder or longer if you did that too much. So let's look at how they simplify that. The key to simplifying that is knowing Pascal's triangle. Pascal's triangle is a triangle that was created by a mathematician that he noticed with binomial expansion there was a certain pattern. And the pattern was like building up this triangle where we go 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. And if you notice here, 1 plus 1 is 2. 1 plus 2 is, there's always ones on the outside. And then 1 plus 2 is 3, 2 plus 1 is 3, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. So on the next one, I've got my ones on the outside, and then I can say 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and then I have a 5. So you can keep building the triangle like that if you think that you're always adding two numbers to create a number down on the next one, and you have ones on the outside. Okay. So now keep in mind these numbers respond to a specific power. Like if this is raised to the third power, this is the row I would use, and you'll see what I mean by that in a second. If I'm raising to the fourth power, this is the row I will use. Notice the 3, the 4, the 5, the exponents line up with the row that they need to be used for. Okay, so let's do that x plus y, but this time I'm going to raise it to the fourth power. So that responds to the fourth row. Now this method here is actually the simplest way to do this. So first, write the numbers 1, 4, 6, 4, 1 from that row on Pascal's triangle. Then let's make those into columns, and you're going to have actually 3 rows. You've already got your first row, 1, 4, 6, 4, 1. The next row is going to be your row for the first term in the parentheses, which is in this case x. And you're going to start off x to the fourth power, and you're going to work your way down. X to the third, x squared, x, no x. On the next row, you're actually going to start on the right-hand side and go from right to left. So we're going to go y to the fourth, then go y cubed, y squared, and y, no y, and then you will multiply downward. 1 times x to the fourth is x to the fourth. So we're going to multiply downward, and like I said, 1 times x to the fourth is x to the fourth. 4 times x cubed plus y times y would be 4x cubed y. 6 times that would be 6x squared y squared. 4 times that, again, like that. And then finally 1 times y to the fourth. So again, the main idea is to make sure whatever's in the first term, whatever that first term is, you're going the power of the parentheses, or that's outside the parentheses, and you're working your way down, and if you have to, put them in parentheses, and then you can multiply straight down. So here's another example. 4y plus 5 raised to the third power. Now the third is 1, 3, 3, 1. You can go back to Pascal's triangle and see the 1, 3, 3, 1. Okay, make my columns. Now I'm going to start off 4y raised to the third power. Notice how I'm putting that in parentheses. 4y raised to the second power. 4y to the first power, no 4y. Then on the far right, I'm going to start 5 to the third, 5 squared, 5, and now I can multiply. 1 times 4 cubed. You can type it in the calculator and you can say 4 cubed, 4 to the third power is 64 times 1 is 64, y to the third power. 4 squared is 16 times 3 and then times 5 would give me an answer of 240. Now again, you can type this in the calculator. You would type 3 times 4 squared times 5, and then you would have the y squared after that. 3 times 4 times 5 squared is 300 y, and then 5 to the third power is 125. And you're done. That's it. There's no like terms combined. They've already been like combined or done whatever. That is it. You are done with that. So if you do it like this, it usually goes pretty quickly. Now the one you have to be careful about is when you have a minus. So for my final example, let's do this one with a minus. With the fourth power, I got 1, 4, 6, 4, 1. Okay, and I'm going to put in 3x raised to the fourth, then to the third, then squared, and then by itself. And notice I'm putting them in parentheses. Negative 7, I'm also going to put in parentheses. To the fourth, to the third, squared, and then to the first. Okay. Then if I do this, 3 to the fourth power is 81, x to the fourth. 81 times 1 is 81. 4 times 3 to the third times negative 7, I would have typed in the calculator, and I get 756. Ray x to the third power. 6 times 3 squared, which is 9, times negative 7 squared, which is 49. And again, this is where this is important. Make sure you put this in parentheses, because that way you won't mess up with your sign. Negative 7 squared is positive 49. Times 9 times 6 should give you 2,646 x squared. Then I can do negative 7 cubed times 3 times 4 and get 4116x, and then negative 7 to the fourth power becomes a positive 2401. 2,401. So that's my answer for that one, and that's it. That's as complicated as those get. They shouldn't be that bad. If you do have any questions, feel free to ask. Send me a question through Edmodo, or make sure you ask in class. That is multiplying polynomials, and that's section 6.2.